So we're going to look at how we can compare fractions when we don't have a number line. So this second quiz involved you in using your knowledge of equivalent fractions to help you do that. So this first question, what sign would make this statement true between the 4/6 and the 10/15? There's a couple of ways of doing this. You could have gone straight to finding your equivalent fractions by looking for the lowest common multiple. So I'm going to write LCM of 6 and 15. So that means I'm going to go through my 6 times table and my 15 times table. It's usually easier to start with a bigger number until you recognise one that's in the smaller numbers times table. So if we were writing out the 15 times table isn't one you would normally know. However, 15 times 1 is 15, 15 times 2 is 30. Hopefully you recognise the fact that that 30 is also in the 6 times table. If we were listing the 6 times table, we'd have 6, 12, 18, 24, 30 and so on. And this one continues as well. But the key thing is spotting that you've got this common multiple of 30. What that allows you to do is then take each of these fractions and change them into 30ths. And then at that point compare them. So with that first one, to change 6 into 30 you would be multiplying by 5. That would mean the top number needs to be multiplied by 5, so you would end up with 20 on the top. With this one, you're timesing by 2, top and bottom, would also mean you'd end up with 20 over 30 when you do that. So having done that, you're then looking to compare, and you can see they both ended up with the same answer, so that actually means that what needed to go in between those would be the equal sign. Now that is not the only way you could do this question. You may or may not have spotted that we could do this question by finding equivalent fractions by simplifying. So you might have spotted that if you simplify 4/6, it's got common factor of 2, top and bottom. So dividing by 2 would get us to the fraction of 2/3. If we also took the 10/15ths, we could spot this time that actually what you can do is divide by 5 this time, and that will get you to the same fraction, so you get 2 over 3. So both of these fractions, 4/6 and 10/15ths, are the same fraction as 2/3, so they are equal to each other. So that one, you could have had 2 different ways to get to the answer. This next one, however, the 9 and the 12 being on the bottom, there isn't, and with the numbers that are on the top, you can't simplify this time. So we do need to look at the method of doing the lowest common multiple. So you are looking at the lowest common multiple of the denominators, which is your 9 and 12. So if you start writing down, pick the bigger number first, so start with the 12 times table. You're going to have 12, 24, 36, and you'd keep going until you found one that you recognised is in the 9 times table. And our 9 times table, right, our 9, 12, 18, 27, 36, and so on. So actually, very quickly, we find that lowest common multiple, a number that's in both the times tables, is 36. So we want to change both of these fractions into something out of 36, and that will allow us then to compare them. So 5 over 9 changed into something over 36, so hopefully you know that you're timesing by 4. Top and bottom, that would mean that the number in here needs to be 20. You would do the same thing with the other fraction, the 7 over 12, so 7 over 12, changing that into something out of 36, and this time we would be timesing by 3 when we do that. So when you multiply by the 3, you get 21 on the top, and at this point you're then able to compare the two fractions, and you can see that actually the 5/9 is only 20 out of 36, whereas 7/12 is 21 out of 36, so it's the bigger one. So the 5/9 being the smaller fraction means that the symbol that would go between them would be the less than symbol, which would be symbol B. The pointy end always points to the smaller number, is the way to remember that. So that's question 2. Hopefully you got that correct. With question 3, you're comparing 3 different fractions. So if we were to write down 3/7 of the cake in the bakery were chocolate. So we've got our fractions that we're comparing is 3/7. And for the vanilla cakes, the fraction that you're looking at there was 5 out of 14. And then the lemon cakes was 6 out of 28. So the bottoms of those fractions, 7, 14, 28, hopefully you can spot that the lowest common multiple, right, the first number that is common to 7, 14 and 28 is in fact 28. So we won't need to change the lemon ratio, but the other two, if we change them into something out of 28, we will then be able to compare them. So what we would be looking for here, right, that would be times them by 4, top and bottom, times by 4, that would give you 12. And if you times this one, to change 14 into 28, that's times them by 2, so times the top by 2 would give you 10. So you're then left with looking at 3 fractions that are all out of 28. You've got 10 out of 28, you've got 6 out of 28, and you've got 12 out of 28. So which flavour cake is there more of? And the answer, right, would be that this one here, the chocolate cake. So answer A would have had more of that. So this all comes down to using equivalent fractions to compare. For number 4, to work out what fraction could go in the middle space that you've got there, or you've got 2 numbers to position, you can sort of go through each of these in turn, or look at the fact that this is in tenths. The first one's given in tenths. Each of the other ones you've got fifths and halves. We could write down what they are in tenths, so we can just tick them off one at a time, decide if it's true. So 4/10 is less than, if I put answer A there, 3/10, would that be true? And I think you'd agree that that's clearly not true. 4/10 is less than 2/5. How would I know that? I would need to change my 2/5 into tenths to compare it. And in order to do that, I'd be timesing top and bottom by 2. And that would give me 4/10. So 2/5 is actually the same thing as 4/10. So it can't be less than, so it's not that one either. And if I was to change 1/5 into tenths, I would find out that that was just equal to 2/10. And clearly 4/10 is not less than 2/10, so I can't be putting that one in there either. So it must be the last answer. And in fact, if you were to change a half and write it in tenths, hopefully you know that a half is equal to 5/10. So it will make sense to say that 4/10 is less than a half. So your answer should have been answer D. Right, last question. How much bigger is 3/8 than 1/3? And again, to compare them, we need to get the bottom numbers to be the same. So you're looking for lowest common multiple of 3 and 8. So that's the first number that's in your 8 times table and in your 3 times table. Pick the bigger number, so 8, 16, 24. Hopefully you recognise that 24 is also in the 3 times table. Right, 3, 6, 9, 12, 15, 18, 21 and then 24. So our lowest common multiple is 24. So that means we're going to write each of those as something out of 24. So we take our 8, we are timesing by 3, and we would need to times the top by 3, so we would get 9 out of 24. We do the same thing with the 1/3, and we have our 1/3 equal to something out of 24, and if you work out with your tables, you're times them by 8, top and bottom, means that you're only going to have 8 here. So how much bigger is the 3/8 than the 1/3? Clearly you can see that the difference between these two things would be answer C, which would be 1/24. So if you check your answers, check your working, and hopefully you've understood if you've got any of them wrong, why you got them wrong, and what you can do to improve on this.